stack using array, that means you are implementing the stack statically, because we know that size is fixed. So here consider your stack. So stack looks like this logically. So since we are implementing using an array, we know that in array the indexing starts from 0 to n minus 1. So this is 0, then 1, this is 5 and n minus 1. So as I told you, here we will be performing the operations, two operations, that is push and pop. And also one important thing which I have mentioned about the top, which is the reference in order to perform this push and pop. So first of all, when your stack, this is your stack, when the stack is empty, in that case the top is -1. You have to initialize it to -1. And one more thing, in case of the array, we know that the elements which will be present will be of the same data type. So here we will store the elements of the data type integer, and we are having this top is equal to -1, that is also of the data type integer. So this will be -1 when your stack is empty. So initially your stack is empty, and we'll see this push and pop, what will happen in that case. So in case of the push, actually what will be the definition? So it will be like void push int val. You're having this. So what all things we are supposed to do actually in case of the push? So the very first thing is that you have to push some value 1. So suppose from the main function I call this push and I'm passing this value 1, which is of the data type integer. Then in that case what will happen, I want to push this 1 here. So now initially my top is -1. So for that I have to first increment my top by 1, because it will then come at index, that is 0. If you increment -1 plus 2 plus 1, then it will be 0. So the very first thing is that I have to increment my top. And now I have to place at this index the value which the user is passing. So the value that is which I am getting in this function in this variable, that is val. So in that case, and also we the stack using the array, we will be representing in, since we are storing, we want to store all the elements which are of the data type integer. So suppose the name of the stack is stack array and this max. So this max, I am hash defining max to some value, say 20. Or you can also, depending upon your requirement, you can give the different value. But you cannot change the size. One you have kept fixed. Accordingly, you have to perform the operation. You have to see the size, and depending upon that, you have to push and pop. Taking into account your stack does not get full or your stack is not empty. So let us see all these things in detail here. So first of all, what we are doing, we are incrementing the top by 1. So we came here, and now we have to push that value, that is 1 here in this position. So for that, what I will do, this is my stack. So in that case, I will simply in this array, since my top is now here actually, so at this place only I have to push. So this will be top equal to the value which the user have sent. So now in this case, this will have this value 1. One more time, push 2. So what will happen in this case? Again this function will be called, right? Again this value 2 will be passed. Again the top will be incremented by 1. So top was 0. Now it will be incremented by 1. Therefore here is your top, this index. And in this array actually, that is at the index 1, you are storing this value, that is 2. So now 2 will be stored here. Now when I call the pop like this. So in case of the pop, you can see here I don't require to pass any value. Why? Because first of all, we know that whenever we have to remove from stack, we don't have any choice. It will be always the topmost element which will be getting removed. And if we have to remove 1, we cannot give here 1. No, that is not correct. So if we call the pop function, it will always remove the element where the top is present. So top is having the index 1, so it will remove this value 2. This, first of all, the return type will be integer, because I want to remove this value and I have to return this value also. So therefore this, and I will not pass, there will be not argument here because we don't have any option where the top is there. Actually there, that value only will be removed. So therefore this pops. So what will happen, this value I will store in some variable because I have to return that value. So therefore if I take int val like this, so first of all this value where it is present in this stack underscore array and this top, because my top is having this index that is 1. Array top I will get this value 2. So I will store it here. This will be my val is equal to, I will do val is equal to stack underscore top. So I will get in val this value 2. Now I want to remove it actually. So simply in this case now I have to, when this 2 will be removed, then what is left, actually we are left with this 1. So in that case you can understand top should be decremented by 1. So therefore I will do here top is equal to top minus 1. So my top is now here, since I have to remove this 2. So top is here, and then I will return this value. So I will return this value from this pop. So it will be returned. So here I am having, suppose in temp equal to, in temp is equal to, so here this value will be returned. So you will get this value which was popped. In this push and pop actually, first of all, what things we have to keep in mind. So first of all, you know, what about the situation when your stack is full? What will happen? How much, suppose my size of the stack is here 6. So here you can see total, if it is 6, so indexing will be from 0 to 5. So in that case, suppose this, all these values are stored. So now here the top is there. So consider your stack is full and now top is here. So in that case, if I am calling again the push function, so what should be the behavior? So I cannot, if I call the push function, then the overflow will occur. If your stack is full, you cannot perform this push operation because the stack overflow condition will arise. So this is the disadvantage in case of implementing the stack using the array, because you statically, first of all, you are giving the size in your program here itself. So beyond that size, you cannot exceed that size. So if you want to still store more elements, actually exceed this limit, actually in that case what will happen, what implementation you are supposed to do if you don't want this overflow to occur in case of stack using an array? So in that case you have to create one more array, and that array actually wherein will be, first of all, the size will be greater than this size, actually that is this old array size. So you can create the size, double size of this array, the new array which is there, and then you have to copy all the contents of this old array to the new array, and in that new array actually then you can perform the push and pop operation. All these things are required if you implement the stack using an array, because the overflow condition can occur. So this is not good actually if you see in this case, because your size is fixed. To keep into picture actually that you have to check the condition of the overflow. Also one more thing, if your stack is empty, so what will be in that case? The top will be equal to -1. So you know that when the stack is empty, as I told, in that case top will be -1, and then you are calling the pop function. So you know that if the top is -1, in that case nothing is there in your stack. That means how you can pop any value from that. So you have to check this condition whether the top is -1, that is if the stack is empty, then you cannot perform this operation, that is pop. So if you can see in case of the stack using the array, what is the time complexity? Push and pop operations are always performed from the top. So you don't need to come down actually. There and then and there you can perform the push and you can perform the pop actually. So it is not dependent on the size of the array. So the time complexity in stack using the array will be big O and 1, because it is independent of the size of the array. But in the case actually when your overflow had occurred, that means your stack is full actually, and you have to simply to come out of that you are creating one more new array that size is greater, double than the size of the old array, and you are copying the whole content. Then the complexity becomes to be O, and in that case, but the average, if you calculate the size, the complexity will be still O1. So here actually a quick question to you with respect to the array. So the program is that you have to simply create an array. You have to define an array. Say you are creating the array of the data type integer, and I simply want you to print all the elements in the reverse order of the array. I want you to write on the IDE and execute it. And if you are having still any doubt actually, that also you can just write in the comment box. I will reply to your comment. Even if you are not running the program, simply what instructions you feel actually, if you are creating the array, if you are defining the array, and if you have to print the elements in the reverse order, what lines of code is required. So what program I want to create array, define the array, that is initialize it with the values, and display elements reverse order. So let's come back actually and let's see about in short stack using the linked list. So this is all I'm just describing you in short actually. In detail we'll be writing from scratch the whole program of stack using an array. So just to make you understand what is the difference between stack using an array and stack using the linked list. So you understood that what is the disadvantage of using the array. First of all, we have to statically give the size in case of the array, and therefore runtime you cannot change the size. So what about if your overflow occurs? In that case, as I told you, we have to create a new array. We have to copy the contents of the old array to the new array. All these things are required, and the time complexity also increases. So in that case, you can go to implement the stack using the linked list, because we know that in linked list, first of all, we don't need to worry about the size, and you can dynamically insert, you can dynamically delete the nodes. So let's see in case of stack using the linked list. Then we will see application of the stacks in short actually, and then in the next session we'll cover all these topics in detail, and we do lots of programs which are important interview perspective.